Now we look at the general properties of all of these blocks. Okay? And after this, we'll solve a lot of questions. Those questions will be JEE level questions. Chalo. So S block is group 1 and 2. This makes up the S block. The properties are, these are called alkali and alkaline earth metals. Okay. So group 1 are called alkali metals and these are called alkaline earth metals. Alkali and alkaline because when they dissolve in water, they are basic in nature. Okay, you know acids and bases, of course. So when they dissolve in water, they are basic in nature, and alkali is just another name for base. That's why they are called alkali. And alkaline earth because magnesium and calcium are predominantly found in the earth's crust. Okay, so in different compounds, magnesium and calcium are predominantly found in the earth's crust, and hence they are called alkaline earth metals. RMN, technically they haven't been discovered. So they are just written in the periodic table for the sake of it, but they haven't been discovered yet. It is very difficult to synthesize those elements because the electronic configuration, you can think about it, I guess. So it's very hard for us to synthesize those. Yeah, they are super unstable. So कोई बना नहीं पाया आज तक उनको to call them appreciable elements. Anyway, alkali and alkaline earth metals. Then you have the property that says these are reactive metals with low ionization enthalpies. People, can you tell me what is metallicity? How do you characterize metallic character? You've studied this in earlier classes as well. What is the property of metals that makes them metals? Yeah. Yes, Abhiram, those are properties, of course. But yeah, they can lose electrons. Okay, that is what chemically metals mean. Okay, Abhiram, you're talking about physical properties, those are also fine, but yes, chemically they tend to lose electrons. They don't want to keep electrons with them. Yeah, we've studied the term ionization in some question in Bohr's model of the atom. Ionization means uprooting an electron. Yeah, so it is very easy to remove their electron. You don't have to give a lot of energy. Enthalpy means energy. Okay, so you don't have to give them a lot of energy in order to take away one electron from them, and hence they are very reactive. Okay, so these are reactive metals with low ionization enthalpies. Okay, reactive because they are easily in the mood to lose an electron. Yeah, alkali metals form +1 oxidation state and alkaline earth metals form +2 oxidation state. Oxidation state basically is just the charge that is there on that particular atom in a bonded scenario. Let us talk about NaCl. Let's take about KCl. Let's talk about LiF. Yeah. All of these cases, Na positive, Cl negative, K positive, Cl negative, Li positive, F negative. So the oxidation state, which is basically the charge on the cation, is +1. Yeah, because of their electronic configuration S1, so that they can lose that electron and become as good as a noble gas. They can achieve their octet by losing that one S electron. Yeah. Similarly, for alkaline earth metals, they form compounds with +2 oxidation state. Something like MgO is found. Yeah. BeCl2 is found. CaO is found, so on and so forth. Yeah. So in all of these cases, the metals are in a +2 oxidation state. Since they have S2 electrons, they can lose both of those electrons to reach a noble gas configuration. Okay. So these exist in +1 and +2 oxidation states. Now, metallic character and reactivity increase down the group. Metallic character is to lose the electron. Now, as you go down the group, you are going away from the nucleus. Now, the further you go away from the nucleus, the easier it is for you to leave the atom, because now you're not that closely attracted towards the nucleus itself. Yeah. So as you go down a group, metallic character always increases. No matter which group you are in, if you go down one particular group, the metallic character will always increase. And since these are metals, yeah, since these are metals, their reactivity is because of their metallicity. So going down the group, their reactivity increases. And because of this high reactivity, they are never found in pure state. Okay, they are never found in pure state. They are always found in bonded state. Sodium is never found as sodium metal in nature. Yeah, it is found as NaCl, salt. We eat it every day. Yeah. Magnesium and calcium salts are present in water. You studied about hardness of water. Yeah. Yogesh will get to nuclear charge later. अभी उसके बारे में discuss नहीं करेंगे. That will take some time. So the next class is for the same. And these are predominantly ionic. Predominantly means mostly the compounds that are formed by these are ionic in nature. Okay, cation alag se, anion alag se. Only lithium and beryllium, okay, are different. Okay, lithium and beryllium form covalent molecules. Lithium and beryllium mostly form covalent molecules because of their small size. So they prefer sharing electrons instead of giving electrons away. Okay, so that is one thing that is observed in nature. These are the properties of the S block. Now let us go to the properties of P block. First statement is that P block and S block are called representative or main group elements. Okay, this is just a name that is given to them. So don't think of why it happens or how it happens. It is just a name that is given to them, that S block and P block elements are called representative elements or main group elements. Okay. Now, halogens and chalcogens have high electron gain enthalpy, which means they want to gain electrons. Okay, we'll see the definition of electron gain enthalpy in the subsequent classes. But the point is that halogens and chalcogens want to gain electrons. I'm sure you've seen that oxygen exists in a O2 negative state, fluorine F negative, Cl negative, S2 negative, so on and so forth. Yeah. These want to gain electrons in order to complete their noble gas configuration. Yeah. So they have high electron gain enthalpy, which means they want to gain electrons. And when they gain electrons, they become very stable. Okay. So by this, we can say that non-metallic character, when you go from left to right, it increases. Very simple, because from left to right, you are getting closer to the noble gas. You can easily just gain an electron and attain a noble gas configuration. The number of protons is also increasing, but the number of electrons is increasing in the same shell. Yes. So because of those reasons, they have a huge tendency to accept electrons. So from left to right, the metallic character decreases, non-metallic character increases. And when you go top to bottom, again, you're going away from the nucleus, hence it is easier for you to uproot an electron. Hence, from top to bottom, metallic character increases. People always remember that metallicity and non-metallicity. Okay. Yogesh, that is taken from some website. उस website पे इसका कुछ meaning था. अब यहाँ पे क्या meaning है, I don't remember actually. Okay, so people, the point is that metallicity and non-metallicity are based on relative concepts. Okay, if I talk about, let's say, fluorine versus iodine, okay, F versus I, which one is more metallic? If I talk about fluorine versus iodine, which one is more metallic, people? Yes, iodine is more metallic than fluorine, but technically speaking, iodine is a non-metal. Yeah, iodine in absolute terms is a non-metal, but compared to fluorine, it is more metallic. Okay, so metallicity and non-metallicity are relative phenomena. Okay. Yeah, exactly, Bhavans. So metallicity and non-metallicity are relative phenomena. Okay, you should not compare them in absolute terms. Whenever you go down in any group, for that matter, the non-metallicity decreases, the metallicity increases. Then let's talk about the D group. These are called Yes, exactly. Okay. Similar happens with acids and bases. Yeah. Acids and bases में भी same चीज होती है. Depends on what you compare it with. Now compared to hydrochloric acid, milk is basic. Although milk also has lactic acid in it. Yeah. So similarly, metallic and non-metallic characters are relative. Depends on what you compare it with. Chalo, D block elements. These are called transition elements. We all know the name. Why transition? Because they are, between S and P block. They form a transition. So that's why they are called transition elements. Okay. Now they exhibit variable valencies. Okay. Most of their electrons exist in D block. Okay. And D block elements have this tendency to exhibit valency which is variable. Okay, so for example, chromium can exist in +2, +3, +4, +5, +6, +7 oxidation states. So can manganese. Okay, all of these oxidation states are possible for these ions because these have so many d electrons in them. D electrons can easily be lost or gained. Okay, so they exhibit variable valencies and hence are used as catalysts. People, can you tell me what catalysts are? What do catalysts mean? Can you tell me what is the meaning of catalyst? Yogesh is saying which increases the reaction process, alter the rate of the reaction, make a reaction occur at a faster rate. Okay. Elements which support a reaction without taking part in it. Yes, exactly. So catalysts are basically something that can aid a reaction without taking part in the reaction itself. Okay. Now you must be wondering, sir, then what does variable valency have to do with catalysis? Think about it. What happens in a reaction? In a reaction, you have electrons going from one place to the other. Yeah. Basically, a reaction is exchange of electrons. Now that exchange is facilitated by these catalysts. Let's say there is a person here, there's a person here. They want to pass a book to each other. Instead of throwing it at each other's faces, okay, let's put a catalyst over here. He can take the book from this guy, give it to this person. Yeah. So this person has acted as a catalyst. Now, in case of electrons, you have to transfer electrons from here to here. This transition element has d orbital in them. It can easily accept those electrons and he can easily give those electrons away. Yeah. And hence they can facilitate reactions acting as catalysts. Yeah. Cool. Then they also form colored ions. Colored ions basically means they give out radiation in visible wavelength. Yeah. So their ions give out radiation in visible wavelength and hence they form colored ions. So I'm sure you've seen potassium dichromate in your laboratories. Its color is very nice and bright. है ना? देखा ही होगा आप लोगों ने. And then lastly, zinc, cadmium and mercury are sort of noble. Okay. These are known as pseudo transition elements or also fake transition elements. Okay. These are also called to have pseudo noble gas configuration. People, can you tell me in zinc what is the electronic configuration? What is the electronic configuration of zinc? Yes, it is a 3d10 4s2. Similarly, for cadmium, it is 4d10 5s2. For mercury, it is 5d10 6s2. Okay. People, just notice that all of these have fully filled orbitals. Okay. Since these have fully filled orbitals, okay, they are not very reactive. They do not show variable valencies. Okay. They are almost as good as noble elements. Okay. So that is why these are known as pseudo noble gas configurations, also called pseudo transition elements, because all of their orbitals are fully filled. They do not exhibit variable valencies. Chalo. With that said and done, let us get into solving some questions. People, first question is very easy. Give me the answer in the chat box. Let's do these 7 in the next 5 minutes. Quickly. Triads were given by Dobereiner. ठीक है. This is done. Second, according to Moseley's experiment, the atomic number is directly proportional to. Second question, people. Atomic number is directly proportional to root of frequency of X-rays that are emitted. Right? Now, the third part. All of the S block elements are metals, non-metals, halogens, chalcogens. Yes, the answer is C. All of the S block elements are metals. What would be the temporary name for element with Z equals to 198? Yes, it is going to be N oct EM. Yes, it will be UEO. ये भी हो गया. These are done. Which one of these is more metallic in nature, silicon or germanium? Which one of these is more metallic in nature? Remember, tin and lead. ठीक है, people. This question, please. Question number 6. In terms of reactivity, you have to sort them in terms of their non-metallic behavior. So higher the non-metallicity, higher will be the reactivity of these. Other people, what's your opinion on the same? I can see only one person giving me the answer. Okay, 2 people have given me the answer. So highest non-metallicity over here is that for fluorine, then chlorine, then bromine, then iodine. Top to bottom, more non-metallicity, more is the reactivity. So this is also done. Then give the electronic configuration and periodic table position of Z equals to 74. Try to figure this out. Electronic configuration and periodic table position. You have to tell me which group and which period this thing belongs to. Think about question number 7. Tell me, क्या होगा इसका? Okay. Got one answer. Okay, lots of people giving me the answer. I am just going to show you how I would solve this question if it came to me. Okay, I would first, since I remember the periodic table somehow, okay, I would have made the periodic table in the paper itself. Okay, but there is one more way, a simpler way in which you can do it. You can also tell me how you did it. Okay, so the numbers of these are 2, 10, 18, 36, 54 and 86. Okay, so this one is 74. Okay, so 14 less than radon is what I'm gonna get. Okay, 14 less than radon is what I'm gonna get. So this is 1, 2, 3, 4, 5 and 6. Okay, so it is gonna lie in the 6th period. Okay, and this is, since this is the 18th group, and you have it 4 kitna 12 less than 86, 74. Yeah, so 12 less than radon. So you can figure out the group as well. Technically speaking, this is tungsten. Yeah, Z equal to 74 is tungsten. So this was one way in which you could have figured out what it is. Ariman, how did you solve it? What was your way of doing it? Did you just add electrons after xenon? Yeah, so that is also one way of doing it. Okay, I personally would have made the whole periodic table and just pointed out where it is. Hardly would have taken me 2 minutes to do so. Yeah. So it is going to be a 5D4. Okay. This is going to be a 5D4. This is tungsten. If you want to look at the periodic table over here, this is the case. Okay. There are going to be 74 electrons in it. 6s2, 4f14, 5d4. So it always helps to remember the periodic table itself. Okay. So these were some simple questions. Now let us get to some more interesting questions. So for all of these four questions, okay, I will launch polls one by one. So tell me this one. In the fourth period of the periodic table, how many elements have more than one 4d electrons? Okay. In the fourth period of the periodic table, how many elements have one or more 4d electrons? So I'm giving you 30 seconds to think about this. Then I will launch a poll for the same. Think about it. You have 30 seconds. I am putting the chat to organizers only so that you don't discuss answers with each other. Okay, giving you 20 more seconds and then I will launch the poll for the same. In the fourth period of the periodic table, how many elements have one or more 4d electrons? Okay, so 36% say A, 18% say B, 27% say C, 18% say D. People just think about the fourth period. Okay, in the fourth period you have a 4s1, 4s2, then you have 4s2, 3d1, going till 4s2, 3d10. Then you have 4s2, 3d10, 4p1, going to 4s2, 3d10, 4p6. Can you see any element over here which has any electron in 4d? People, can you see any element over here which has any 4d electron in 4d? No, right? So the answer is 0. This is actually a good JEE advanced problem. Okay, you can see by the percentages how people can do silly mistakes in the same. This is a very nice problem. Okay, chalo, this is done. Let us solve the next question. Question number 9. I am putting the chat to organizers only once again. If the Aufbau principle was not followed, Aufbau principle is increasing order of energy is the order of filling of electronic orbitals, N plus L rule. If that was not followed, calcium would have been placed in which block? The options are S block, P block, D block, and F block. I am giving you another 30 seconds to think about this problem. Think about it. You guys have 30 seconds. The chat is to organizers only, so you can send in your responses as well if you want to. Ariman, yes, you are correct. Bhavansh, सोचो सोचो सोचो. Aufbau principle follow नहीं होता तो क्या होता? You guys think once again. If Aufbau principle was not followed, then what would be the case? Nandini, yes, you are correct. ठीक है, people, giving you 10 more seconds and then I will launch the poll in front of you. Yeah. 8% say A, 54% say B, 38% say C, and 0% say D. Okay, let us try to think about this question. People, we are talking about the Aufbau rule to not be followed. Aufbau rule is the N plus L rule, in which for certain cases we have to fill the higher shell first and then the lower shell orbitals. Yeah. So in order to think about this answer, okay, calcium is 20, Let us try to fill the electrons one by one without following the off-bow rule. So 1s2, then you have 2s, 2p, 3s, 3p, 3d, so on and so forth. Yeah. Generally, because of the off-bow rule, you fill a 4s here, but this is what you don't have to do. Yeah. So you will have 1s2, 2s2, 2p6, 3s2, 3p. आएगा 3p में कुछ कितना आएगा 6, 7, 8, 9, 10, 11, 12. 3p6, how many electrons are remaining? 2 more electrons. This is what goes to 4s2, but now it will be going to 3d2 if the off-bow rule is not followed. Okay. Hence, the last electron goes into a d orbital. This would be a part of d block. This is also a previous year JEE advanced problem. Okay. So if the off-bow principle was not followed, it would have been placed in the d block. Okay. Now, let's focus on the next question. Lanthanum, having atomic number 57, is a member of S block, P block, D block, and F block. This is a little tricky, the question. Yogesh, this was the question that you were asking me. सोच के देखो. Look at the electronic configuration of lanthanum if you want to. Okay, I'm giving you that liberty. If you want to see the electronic configuration of lanthanum, you can see. Vaibhav, nahi yaar. Socho, socho. Bhavansh, think again. Just look at the electronic configuration of lanthanum. Open ptable.com. Look at the electronic configuration of that. You have to put these elements in place because of their last electron. Bhavansh, again, look at the configuration. Don't look at the position over there. Look at the configuration of lanthanum. Okay. People, I'm giving you 20 seconds. After 20 seconds, I will start the countdown to launch the poll. I'll explain this question. It's a tricky one. So please think about just the last electron and where it goes. 18% say A, another 18% say B, 36% say D, and 27% say F block. This is correct, people. Now you must be wondering, sir, but in the periodic tables it is placed in the F block. Okay, I'll explain. What happens over here is if you look at lanthanum, okay, its electronic configuration is a 5d1. Lanthanum electronic configuration is 5d1. Since its last electron is in a d1, its position is over here. Okay, just look at where my cursor is, this white thingy. This is where its position is going to be. Now, just for the sake of representation in the table, just for the sake of showing it in the table that okay, lanthanum is here, actinium is here, and here is the series. Okay, just for the sake of visual representation, they are placed here. Otherwise, their position is in the D block itself. So always remember that lanthanum and actinium are D block elements. Okay, keep this in mind. This is something that I put as a question for obvious reasons. Always remember this. Lanthanum and actinium are a part of D block, but just for visual representation, they are kept in front of the F block in some diagrams. Okay, so technically they are part of the D block elements. Okay, Ariman, lutetium is the F block. Okay, this is a funny thing. They are in the F block because lutetium may you have 4F14 5D1, 4F14 gets filled later, and lawrencium may you have 5F14 7P1. So they are placed in the F block. Yeah, Ariman, it is shaded green to tell you that these are the end. Okay. That is something that is sort of, you know, a weird thing about the periodic table, but always think about the last electron and where it goes. Okay, so since this question actually came in JEE Advanced, I don't know why it did, because it is sort of a tricky question. That is why I've showed it to you over here. But yes, I totally agree with you. These also are kind of confusing in their own sense. But always remember that according to JEE, lanthanum and actinium are in D block, because that's where the last electron goes. Chalo, ye ho gaya. Now people, the last question. This is a relatively easy question. I'll put the chat to organizers only once again. The electronic configuration of an element is so on and so forth, 3p3. What is the atomic number of the element which is just below the above element in the periodic table? This is an easy question. सोचो सोचो दोस्तों. It's not that hard. It's pretty easy. Most of you are getting it correct, by the way. Most of you. Okay, another 20 seconds and then I'll launch a poll for this one. %20 say A, 10% say B, 40% say C, and 30% say D. People, all that you had to do is take this element, okay, and add 18 electrons to this one. Okay, that's all. So 3 plus 2 plus 6 plus 2 plus 2. This is 15. 15 plus 18 is how much? That's all you had to do. Now, for those of you who were confused, ki sir, ab kitna add karna hai? 13, 18, 15, what should we add? We don't know. If you remember the periodic table, this question becomes even more easy actually. Okay, so you have a 3p3. Now the one below it will be a 4p3. Yeah, 4p3 is the nitrogen family. So just go over here and see. Okay, so this 36, 35, 34, 33. This is P5, P4, P3. Okay, this is another way in which you could have done it if you remember the periodic table, or if you remember just the last line of the periodic table. So both ways were, you know, almost equally time consuming, I think. And yeah, the answer to this is 33. The exact element that is there is going to be arsenic, I think. Yeah, arsenic. Yes. So people, with this, let us do the summary and homework of today's class. Right. So what we did today is we saw the old periodic tables. We also saw the modern periodic law. Yeah, how we discovered atomic number Z, which is proportional to root of emitted X-rays frequency. Now, then what we saw is how electronic configuration is actually as good as writing the periodic table. Yes, it is as good as writing the periodic table itself. Then we saw the properties of SPDF block elements. We also saw some temporary nomenclature. Yes, and after seeing all of that, we solved a lot of questions. That is what we've done in today's class. And all of these questions we did at the end. The last 4 or 5 questions were JEE advanced level. Okay, so you see, just in one class of periodic properties, there are so many JEE level questions that we can solve. Yeah. So the homework for you would be start reading the NCERT of this. Okay. You should start reading the NCERT of this chapter, and it is very easy. It is small. It is not much, so you can start doing that. And let me see if you can attempt any tutorials. I am hoping that you guys are working on the exercises of the atomic structure chapter as well. Yeah, there are so many exercises there. So I hope that you are working on that as well. Do tutorial 1. Okay, no problem, Nandini. All right, people. So that's it for today's class.